Okay, so for 37, and like you want to think this would be on the portion of your test that doesn't have your calculator. Okay, so we're finding domain, the vertical asymptote, the x-intercept, and then we're going to graph it. So the first thing you want to do is make this y equals negative log base 2 of x plus 5. And then I want to get it into exponential notation. Before you can convert it, you have to have just the log on the side by itself, not even the negative. Just this has to be here, which means the first thing I'm going to do is subtract the 5. So it would be y minus 5 equals negative log base 2 of x. And then I would multiply everything by the negative 1. So negative y plus 5 equals log base 2 of x. Now the log's on the side by itself, so I can convert it into exponential. So 2 comes over and picks up that whole thing. Negative y plus 5. And then my t-chart, because it's logs, I plug in for y. So I would do 2 to the negative 1, negative 1, so it's positive 1 plus 5. And then I'm going to do 2 to the negative 0 plus 5. And then I'm going to do 2 to the negative 1 plus 5. So 2 to the 6, so 64, yeah. 64, 2 to the 5th, 32, and 2 to the 4th, 16. So 64, 32, God bless you, 16. And then I graph. So because it's so huge, obviously I would adjust my, like maybe go by 20, 40, 60. The y is fine. So 64 negative 1 would be here. 32 0 would be about here. And 16 1 would be about here. And then it's a log, so I know it takes that shape. But even to help you confirm that, you should look for your vertical asymptote. So the vertical asymptote comes from setting whatever's in the parentheses or just that x if there's no parentheses equal to 0. So I have a vertical asymptote at x equals 0, which means that this curve is going to get closer to 0 without physically touching it. And then your, what else did it ask for? Your domain, because it's restricted based on your vertical asymptote, my domain is 0 to positive infinity. And remember with logs, it adjusts with a horizontal shift. So exponential, the range adjusts with a vertical shift. Logs, the domain shifts with a horizontal shift. And then x-intercept we can get from our chart, 32, 0.
With like vertical and horizontal asymptotes, like if you don't have a parentheses, is it 0?
Yep.
Okay.
For logs.
So,
Yeah.
So when you're doing this, before you change the exponential format, you have to
Like if there's anything adding or subtracting from the log, it's got to get moved. If there's a negative on the front, it's got to get moved. If it was being multiplied by 2, it's got to get moved. The only thing that can stay is if there's parentheses, and it said x plus 2 in those parentheses,
Okay.
that stays until you exponential and then add it or subtract it.
Also, so if it's not parentheses, you have to move it before.
Correct. So look at 40. I have to move the 3, but the plus 2 is fine. So I have to move the 3 over. That becomes the exponent when it on the 5, right? So then the 5 comes over and picks up the y plus 3. And then I've got x plus 2 on the other side. Then I subtract the 2. So if it's in the parentheses, it's going to happen after you switch it. If it's outside the parentheses or negative, it's got to have to move before you switch it.
Okay.
You're welcome.
So whenever you have like a log and an ln, it has to have the vertical asymptote.
Yep. Exponential has the horizontal asymptote and the restricted range. Log has a vertical asymptote and a restricted domain. They are the inverses of each other. Other questions on the review? Yeah.
For the interest problems, could you like put it into like the graphing calculator and then like use the table?
It just might not be within the range on your table. It's easier to type it in, but sure.
Okay.
It's just like if it's year 45, do you want to have to keep going? Yeah. And actually, on that note, mistakes made on the quiz, I looked to see if it was your formula. If your formula was right, I gave you back credit. So if you don't write out your formula and you get it wrong, it's all the way wrong. So make sure you're writing out your formula. And then that way, hopefully it's not calculator error. Hopefully we're a little more comfortable with what we're using tomorrow. But if you're using something for the first time tomorrow and you accidentally type it in wrong, I fall back on And everything's 5 points with the exception of the graphs, those are double. But everything else is 5 points. So if you type it in wrong and you don't have that formula written out, it's 5 points gone.
Can you do number 7?
Mm-hmm. So 21 says a new SUV costs $32,000. The value V of the SUV after T years is modeled by V of T equals 32,000 times 3/4 to the T. It says use a graphing utility to graph the function and then find the value of the SUV after 2 years. According to the model, when does the SUV depreciate most rapidly, and is this realistic? So if you graph it, actually it's probably easier for me to graph it on this, but when you graph it, it's so big that you have to really zoom out. So let me do that first. All right, so your graph looks something like that, okay? B says find the value of the SUV after 2 years. You can actually look at the table where T is 2, or my advice is do it without the graph because you don't need it. If I want to find out what the value is when T is 2, I just take this and I plug 2 in for T. So 32,000 3/4 to the second power. And then use your calculator. So 32,000 3 divided by 4 to the second power. And I get 18,000. And C says, according to the model, when does the SUV depreciate the most rapidly? And you can see like the steep decline, right? So between like this year and this year, or that time and that time, which that's your years, that's probably the most rapidly. So you can say like any time between, if you could actually find out where that asymptote's happening, between that time frame, that's when it's the steepest. And then it even if you went all the way to here. And then it flattens out. And the question is that realistic? If you think about like a car, if you ever think about a car, like as soon as you drive it off the lot, if you have a conversation with your parents about your car, as soon as you drive it off the lot, if it's a brand new car, it's depreciated. You've already lost a whole bunch of value. So it makes sense that in the beginning, you lose the most value. When your car is, 15 years to 16 years, there's probably not as big of a differentiation as 0-1 to 0-2. So that's what that means. As far as like a word problem on your test, you're not going to need to graph it. You might see something with an exponential function, that kind of thing. So as long as you can plug that value in and find it, you should be fine. Any other questions from this first page? Okay, so it says in the exercises, approximate the log using the properties of logs. Given the values of log base b of 2 equals log base b of 3 and log base b of 5. So you have to take what's there and rewrite it in terms of one of those logs, right? So log base b of the square root of 5 is the same thing as log base b 5 to the 1/2, because the square root's the same thing as the 1/2, right? Bump that 1/2 to the front and I get 1/2 log base b of 5, and then log base b of 5 gets replaced with this. So 1/2 of 0.8271 is 0.41352. Does it say to round it? No. On the test, most of them say like round to 3 decimal points or 3 decimal places. Money does not say what to round to. Realize that it's money, so that should be 5.5, not 5.3. Money should be raised to or rounded to 2 decimal places, and then if it wants anything else, it's going to state it. Yep.
And do you always have to bring the exponent in front of the log, or can you like plug in the numbers with the square?
But you can't replace this without impacting that.
Okay.
So you have to move the 1/2 to the front, unless it cancels completely. Like unless it was like log base b of b, that becomes what the exponent is. That's when you can cancel it out. But if it's something that's different values, you can't just cancel it out, and you can't plug values into there. You got to bump the 1/2 to the front. Otherwise, you're raising that number to the 1/2, which is not the same thing as multiplying by a half. Yeah. Okay, 78. So this time we're condensing, right? The 3 on the front here, it's going to get bumped to the back here, which means it goes to both of the things on the inside of those. So the first thing you have to do, you got to kind of work innermost parentheses first, and then I can take that exponent of the 3. So if I rewrite just by bumping here, five squared, that's just bumping my exponents back, right? Oh wait, this has another set of parentheses. Then I would condense what's inside the parentheses here. So ln of x minus this 2 goes to the exponent on the x squared plus 1. So ln of x squared plus 1 squared. All of that's raised to the third plus ln, and I can change that already to 25. Then I got to condense again inside the parentheses because there's 2 ln's. So I'd get ln of x, and that's a minus, which means x over x squared plus 1 squared. All of that is being raised to the third power. So you could, if it was only that, you could actually leave it like that, but the fact that there's another ln means I even want to go further with that. I want to distribute that 3 to both the top and to the bottom. So they're both being raised to the third power, which means it's x to the third over x squared plus 1 squared raised to the third is to the 6th plus ln of 25. And then still 2 ln, so you want to condense it down so it has 1 ln multiplication because they're both that's positive. 25 x to the third over x squared plus 1 raised to the 6th. Now it's all 1 log condensed.
You wouldn't want to distribute that to the 6th power?
No, don't even waste your time because you can't like distribute it. You'd have to FOIL that out. 6, yeah.
Oh,
Yeah.
Can you show again number 6?
All right, so we're expanding, right? That's what the directions say? Yeah. All right, so this would be log base 10 of 5 plus log base 10 of the square root of y minus log base 10 of x squared. Then I can take this, make that 1/2 log base 10 of 5 or log of 5 plus log y to the 1/2 minus log x squared. The exponents get bumped to the front. If this is something that could be simplified, I would simplify it. You can even say that's 10 divided by 2. So it gets tricky, right? Because I could say that this is log of 10 divided by 2.
How do you just get log 5?
Because the 5's here.
You're not writing the 10. That's why.
Yeah. You don't need it. 10's the only one you don't need.
That's why I was confused.
Yeah. So I would say if it's like a multiplication, I would expect to see that broken down. If that said log of 50, I would expect to see it expanded as log of 5 times log of 10, and then log of 10 simplified. If it's division, I probably wouldn't mark you wrong if you didn't expand it. Okay, so 105 says directions are here, solve, and then round your result to 3 decimal places. So 105 has 1 log or ln in this case on one side of my equal sign. So the first thing I'm going to do is convert that into log base e. So log base e of 3x equals 6.4. And then I want to convert it into exponential, right? So e to the 6.4 equals 3x. And then this would be on the calculator portion. Second e 6.4. Don't round that though. Like you get 601.8450379. Don't round it. Keep that in your calculator and then just divide it by 3. So I would do this together and I get 200.615. Isa. Oh, go ahead.
And if we want to run it, you just cross out all the log.
Once you condense it, so you got to condense it so that there's only 1 log on either side of the equal sign. It has to be the same log in the base, right? So log base 4 happens once on either side of the equal sign, and then solve it. So if it's log base 4 of x minus 1 equals log base 4 of x minus 2 over x plus 2. Now you've got 1 log on either side of the equal sign, and this is where you can do the one-to-one property. So I get here, I'd multiply both by x plus 2. I'd FOIL this one out. These cancel. X minus 2, x squared, plus x minus 2. Subtract the x, add the 2. And I get x squared equals 0 for this one, right? So if I go solve that, I get x equals plus or minus 0 or x equals 0. And then these are the ones that if there's a log, you have to check. So if I plug 0 back into the very first one, I get 0 minus 1, and I can't find the log of a negative number, which is why this gets ruled out. If it doesn't work when plugged back into any of the individual logs, you cancel it out. So as soon as you see 1e, the goal is isolate it and then ln both sides. So I'm going to 2e to the x minus 3. I'm going to add the 1 to the other side. That's 5. I'm going to divide both sides by 2. E to the x minus 3 equals 5 over 2. And then once you get the e on the side by itself, with the exception of its exponent's fine, I'm going to ln both sides of this equation. So ln of e cancels, leaving you with just the exponent. And then I'd get ln of 5 over 2. And then to solve, I would add the 3. So without a calculator, it would stay like this. And then with a calculator, I would do ln of 5 divided by 2 and add 3 to it, which is 916. You're welcome.
Can you put the answer for number?
Okay, so 99. The directions say just solve and then round to 3 decimal places. So negative 4, 5 to the x equals negative 68. So I would actually divide both sides by negative 4. And I get 5 to the x equals, and this simplifies to be 34 over 2, or 17. And 2 different bases, right? If I can't change one base to be the other, which they can't, there's no way I can make 5 or 17 become 5 to a certain power. You have to ln both sides. So I ln here and I ln here. I get ln of 5 to the x equals ln, or you could do log. I said it before, but you could use log or ln there. Okay. And then the x comes to the front here. I'd get x times ln of 5 equals ln of 17. And when I want to get x on the side by itself, I just divide both sides by ln of 5. And this is a question that would be on the calculator portion. I would say not all, but most of, except for the 1-to-1 property ones, most of 3/4 is on the calculator part. And ln of 17 divided by ln of 5 is 1.760. So if they're different bases and you cannot change them to be the same, then you're going to ln both sides of your equation. Bump the exponent to the front and solve. You could use log as well. Yep. Emily, what'd you say? Okay, 93. ln of x minus 1 equals 2. So ln is the same thing as log base e. X minus 1 equals 2. The e comes over and picks up the 2, leaving the x minus 1. And then I would add the 1. So e squared plus 1 is what x is. Without a calculator, it would stay that way. And with a calculator, I would do e to the second plus 1. Which is 8.389. So if it's e, we ln it. If it's ln, we do log base e and exponential. If it's log, we do log base 10 and exponential. If there's a log on either side of the equal sign, we use 1-to-1. All right, so this is one in which we factor, right? So I'm going to factor e to the x and e to the x, and then I'm looking for the factors of positive 8 that sum to negative 6. So this would be, good, negative 2 and negative 4. Set them each equal to 0. And I get e to the x equals 2 and e to the x equals 4. When I have one e, I'm going to ln both sides. So I get ln of 2 equals ln of e to the x. This is just x equals ln of 2. Without a calculator, it would stay as ln of 2. With a calculator, it's 0.693. And then same thing on the right, ln and ln. I get ln of e to the x equals ln of 4. ln of e cancels, leaving you just the x. Without a calculator, it'd be ln of 4. And with, it'd be 1.386. So 0.693 and 1.386. Or ln of 2 and ln of 4. All right, this is 95. So 3 times e to the negative 5x equals 132. I'm going to eventually ln both sides of these, but you have to get rid of that 3 that's attached to the e first. So I have to divide both sides by 3. And I get e to the negative 5x equals, that's 44. Now I can ln both sides. And I get ln of e to the negative 5x equals ln of 44. ln of e cancels out. I get negative 5x equals ln of 44. And then I would divide both sides by negative 5. So ln of 44 divided by negative 5 is how it would say without a calculator. But with one, ln of 44 divided by negative 5, 0.7568, so 0.757. Negative.
Would it not work since you're not
So the ones you have to check are the when they start with the log or the ln. E can be raised to positive or negative, but like if I got an answer down here that was negative, right, that's when I would rule it out because I can't find the ln of a negative number. So like perfect example,